In this section, I'll be discussing NURBS, which stands for Non-Uniform Rational Basis Spline. Basically, it's a kind of specialized mathematics that represents curves and curved surfaces with extreme accuracy. Accuracy is necessary in fields like automotive and industrial design, where the 3D models that are made are converted directly into objects. Computer numerical controlled machines can output objects from NURBS because NURBS are defined at every point within their description. It's not possible to use polygonal models for this kind of output. So these special industries have to use NURBS. We in the architecture, engineering, and construction industry can use NURBS because they're part of Max and Viz, and I like to use them when I'm modeling furniture that has a lot of curvature, and sometimes for architectural objects like modern roofs that have specialized curvature. I also like to use NURBS for walls, and we'll get into that later. But let's just start exploring NURBS, and I think the best way to begin is to look at NURBS curves. Go to the Shapes category and select NURBS curves. There are two kinds, the point curve and the CV curve. First, the point curve. I'll click some points, and you'll see that we're drawing a curve that is connecting those points. I'll right-click, go to Modify, and expand the object. It has two levels, point and curve. If we want to change the form, we'll go to the point level, where we can access these points, and we can transform them. You can even pull them up in Z to create a three-dimensional object. It's a little like making an editable spline, but the difference is these points don't have handles that you can use to change the curve. Instead, the curve has to pass through these points, so the form is really just a matter of the position of these points. But what if you want to have a straight segment? Is that possible? Yes, it is, by putting points on top of each other so that they're coincident. I'll refine the curve by adding additional points. It doesn't change the shape of the curve at all. But now if I move this point closer to the other one, you'll see that the curve seems to collapse down like that. And we can do this accurately by using Fuse. Fuse works like this. Select one point and then another, and the first one is moved on top of the second one. I'll fuse these 2 points together now. Now we have some straight segments. I'll select this point, and you'll see that there's only one there, and we know that we put 2 together. We fused 2 points together there. But the interesting thing is that when they're fused, they behave as one. You can unfuse them, and that will create 2 separate points at that position. See? Now I can move one of them apart to regain a curve in that area. Let's create a CV curve next. This is the type that I prefer because it gives you more control. Notice that the points that I'm clicking aren't on the curve. Instead, they are the location of what we call control vertices, or CVs for short. I'll go to the curve CV level, and here I can transform the individual CVs to give shape to the curve. I'll pull that up in Z to make a three-dimensional object. Now the difference with CVs is that they're connected by this lattice shown in yellow, We can display that or not, and I prefer to leave it on. The CVs have the advantage that they have weight. I'll increase the weight and it pulls the curve closer and closer to that CV. If I have an extreme weight, it will almost look like a straight edge, but in fact it will never be a corner. We can go back, let me set this back to 1 at the default weight, and now I will decrease the weight, and as it approaches 0, it pushes the curve away from the CV. I'll go back to 1. Now, if I wanted to have a straight line here, I could refine the curve and add additional CVs. Then I can fuse those CVs together, and then we'll have a straight edge there. You can also insert, and insert works a bit differently. It maintains the shape of the lattice, but the curve will change shape. So if I insert a few CVs here, it will pull the curve much closer to that lattice, essentially making it straight like that. Let me just undo a few times to go back to our original shape. Another thing about weight that I'd like to point out is that weights are relative. If I increase the weight of this CV and pull the curve towards it, that's all fine and good. But if I go over here and increase the weight of this one, it will pull the curve back away from that CV because it's relative. Increasing the weight of all your CVs will have a negligible effect. So weight is really useful when you just want to pull the curve closer to 1 or 2 CVs for some refinement of the shape of your object. So that's the basics of NURBS curves. Play around with them and get a feel for them before we go on to NURBS surfaces.